Alright, tomorrow when you walk in for the test, you're going to get a small piece of paper very similar to the one you got today in class. You're going to fill out your unit circle as best you can, and you're going to hopefully write your tangents on it, and you're going to go ahead and write your positive tangents and your negative tangents. You also need to know your formulas. That'll be for double sine and for double cosine. Pick one of the cosines. You don't need to know all three of them. So the rest of this video is going to focus on the review sheet and walking you through it and seeing and pausing the video and checking your answers, that kind of stuff. It says use the information about the angle theta, where theta is between 0 and 2 pi, to find the exact value of each. They tell me that sine theta is equal to 4 over 5 and that theta is between 0 and pi over 2. So what that means to me is that theta is between 0 on the circle and pi over 2, which puts me in quadrant 1. In quadrant 1, everything is a positive. They gave me sine, so they gave me the y, and they gave me the r. So y is equal to 4, and r is equal to 5. I'm then going to go use my formula to find x. X squared plus y squared equals r squared. We don't know x, so x squared plus 16 equals 25. 25, take away 16 is 9, and the square root of 9 is 3. Then all I have to do is plug into my formulas. I know the formula for sine 2 theta is 2 times sine theta times cosine theta. So 2 times sine is y over r times cosine. Cosine is the x over the r. And then we're going to multiply all the tops. We're going to multiply all the bottoms. And we end up with 24 over 25. And that one's done. Number 2, we're going to use our cosine double angle formula. And again, I like cosine squared theta minus sine squared theta. So cosine is 3 over 5 squared minus, excuse me, sine is 4 over 5 squared. So if I square the top and the bottom, I get 9 over 25 minus 16 over 25. If I subtract, we get negative 7 over 25. And you're going to do the exact same thing for 3 and 4 and 5 and 6. So pause the video and see if you can go do 3 and 4 and then come back and check your answers. So let's check our answers for number 3. On number 3, they gave me tangent, so they gave me the y value and the x value. I'm going to go figure out what quadrant I'm in. It looks like I'm going to mark the pi and the 3 pi over 2, which means I'm in quadrant 3. Because I'm in quadrant 3, x and y are both going to be negatives. So my y value is negative 12 and my x value is negative 5. I'm going to go use my formula again, x squared plus y squared equals r squared, to find r. So x squared plus y squared equals r squared. So x squared is 25, y squared is 144. 125 plus 144 is 169, and the square root of 169 is 13. And r is always positive. Now I'm just going to go plug into my formula again, just like we did a second ago. I'm going to have 2 times sine, excuse me, sine is negative 12 over 13, times cosine, negative 5 over 13. I'm going to multiply all the tops, and I get negative 120, because a negative times a negative. And then all the bottoms, we get 169. So positive 120 over 169. We're going to go do my cosine double angle. So I'm going to have cosine squared, so negative 5 over 13 squared, minus sine squared, negative 12 over 13 squared. Negative 5 squared is 25 over 13 squared is 169. Negative 12 squared is 144. 13 squared is 169. 25 take away 144 is a negative 119 over 169. Okay, again, pause the video, go try number 5, and then come back and check your answers. Okay, they gave me cosine, so they gave me the x, and they gave me the r. They're telling me that I'm at 3 pi over 2 and 2 pi, so I'm in quadrant 4. Because I'm in quadrant 4, my y is going to be a negative. So I know x is 3, I know r is 5. I'm going to go plug into my formula again. So we've got x squared plus y squared equals r squared. So 9 plus y squared equals 25. Subtract 9. Y squared equals 16, and the square root of 16 is 4. But we're going to remember that it's negative because I'm in quadrant 4. Again, same formula. 2 times sine times cosine. So 2 times negative 4 times 3 is negative 24. 1 times 5 is 25. Remember that 2 is always over a 1 every time we do one of those problems. Cosine double angle is going to be cosine squared. So 3 over 5 squared minus sine squared is negative 4 over 5 squared. It gives me 9 over 25 minus 16 over 25. And 9 minus 16 equals a negative 7 over 25. Okay, so hopefully you feel really comfortable about your XYR problems and using your double angle formulas. The next part of the review is going to focus on solving trig equations. When you solve a trig equation, if the trig word, sine, cosine, tangent are all by itself, you simply go to the unit circle to get your answers. So on 7 through 15, you simply go to the unit circle to get your answers. So I'm going to go do 1 or 2 of these. I'll go do this first row, and then you'll pause the video and you'll try the next 2 rows and then come back and check your answers. So on number 7, it's saying they want to know where on the circle does cosine equal 1/2. You have to remember that cosine is x on your circle, so you're looking on your circle for where x is a positive 1/2. So x is positive 1/2 at pi over 3, and x is positive 1/2 at 5 pi over 3. So I have 2 answers, pi over 3 and 5 pi over 3. So pi over 3, comma, 5 pi over 3. And it's that simple. Okay? When they ask you about sine, they're asking you about your y. So you're going to go on your circle, and you're looking for where is the y value equal to root 2 over 2. So this time I'm looking over here in the y section. There's a root 2 over 2 at pi over 4. There's another root 2 over 2 at 3 pi over 4. When I come down here, it's negative, so I don't want that one or that one. So I just want at pi over 4 and 3 pi over 4. Then they ask me about tangent for the next one. We wrote our tangents on our circle. So I want to go find where tangent is root 3 over 3. And tangent is root 3 over 3 everywhere I see a divided by 6. So at pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. All the over 6's is going to give me root 3 over 3. However, it's going to be a positive root 3 over 3 in quadrants 1 and 3, and it's going to be a negative in quadrants 2 and 4. So the problem I'm working wanted me to find tangent of a negative root 3 over 3. So I'm going to pick 5 pi over 6 and 11 pi over 6. That's where my tangents are negative, and that's where I get my root 3's over 3. So 5 pi over 6 and 11 pi over 6. Okay, go ahead and pause the video and try to do the other 6 real quick, and then come back and check your answers. So number 10 should be 7 pi over 6 and 11 pi over 6. Number 11 is going to be pi over 4 and 5 pi over 4. Number 12, excuse me, it's going to be 3 pi over 4 and 5 pi over 4. Number 13 is going to be pi over 3 and 2 pi over 3. Number 14 is going to be pi over 3 and 4 pi over 3. And number 15 is going to be 5 pi over 6 and 7 pi over 6. All right, so on 16 through 25, these are going to require that you solve first and then go to your circle. So when I did these in class, what I usually did most of the time is I changed the word cosine, sine, tangent, whatever trig word they gave me, to x until I was done solving. So for instance, on number 16, I would start off by changing the word cosine to x, and I'd say x plus 2 equals 3, and I'd solve for x. So I'd subtract 2 from both sides and get x equals 1. And then I'd go back and change this x to a cosine. And I want to know where on the circle does cosine equal 1. So I go to my circle. Cosine equals 1 right here at 0. So my answer is 0. Okay. Number 17 is the dreaded problem that nobody likes, because I'm going to go around the circle 4 times. So the first thing you want to do is find out where on the circle does sine equal root 2 over 2 just going around 1 time. So here's my circle. And sine is a positive root 2 at pi over 4 and at 3 pi over 4. That's going around 1 time. Now what I have to do is I have to add 2 pi to both of these to get the second answer. Then I have to add 2 pi again to get the third answer. 2 pi one more time to get the fourth answer. So I'm going to fill out some scratch work for this particular problem. So here we go. I've got, so far, I know 4 theta equals pi over 4, comma, 3 pi over 4. That's going around 1 time. So all my scratch work is going to be right over here. I'm going to take each of these answers and add 2 pi. In order to add 2 pi, I have to put the 2 pi over 1, and I have to get a common denominator. I know that my denominator needs to be 4, and it's a 1. So I'm going to multiply top and bottom by 4. So 2 pi times 4 is going to be 8 pi, and 1 times 4 is going to be 4. So I'm going to really add pi over 4 plus 8 pi over 4. So 1 pi over 4 plus 8 pi over 4 is 9 pi over 4. I'm going to do the same thing down here. I'm going to get a common denominator by multiplying top and bottom by 4. So 2 pi is going to change to 8 pi over 4. I'm going to add the tops, 8, 9, 10, 11 pi over 4. So I have 2 more answers because I went around 2 times so far. Okay? I'm going to go around again. So when I go around this next time, I take the answers I just wrote down, 9 pi over 4 and 11 pi over 4, and I'm going to add 2 pi again. Well, hopefully you can see now that when I go add 2 pi over 1, I need a 4 again. So it's going to be the exact same thing happening again, 8 pi over 4. So add the tops, 9 plus 8, 17 pi over 4. The same thing happens down here. It changes to 8 pi over 4. I add the tops, and I get 19 pi over 4. So those are my next 2 answers. So 17 pi over 4 and 19 pi over 4. All right, so I got to do it one more time, and I'm hoping by this time that you can do some of this without having to write everything down. So you have 17 pi over 4 plus, and we're going to have 19 pi over 4 plus. I already know that my denominator is going to need to be a 4, so I know I'm going to want this 8 pi over 4. It's the same as 2 pi. I just already have gotten the common denominator twice, and I'm tired of doing it. So 17 plus 18 is 25 pi over 4. And then 19 plus 8 is 27 pi over 4. So those are my next two answers. 25 pi over 4 and 27 pi over 4. Okay, so with all that said, one time around I added 2 pi. Second time around I added 2 pi. Third time around I added 2 pi. So we know that 4 theta equals all of this. But I don't want 4 theta, I want 1 theta. So what we said we were going to do is we're going to multiply both sides by the reciprocal of 4. Well, 4 is really 4 over 1, so the reciprocal of 4 is 1/4. Alright, so I have to go multiply every single one of these by 1/4. So all the tops are going to stay the same because I'm multiplying by 1. So 1 times pi is pi, 3 times 1 is 3 pi. All the bottoms are 4, and I'm multiplying by 4, so they're all going to change to 16. So I'm going to go ahead and write my answer right here on the review sheet. So theta equals pi over 16 and 11 pi over 16. And then I'm going to have 9 pi over 16 and 11 pi over 16. And it's going to keep going. I'm going to have 17 pi over 16, 19 pi over 16, 25 pi over 16, and 27 pi over 16. And there you go. That's number 17. And you will have a problem on your test where you have to go around multiple times. All right, let's go look at 18. 18 is a little easier, so we do an easy one again. So on 18, I'm going to change the word cosine to x again. So 4x plus 2 equals 0. I'm going to subtract 2 from both sides again. So 4x equals negative 2. I'm going to divide by 4. So x equals negative 1/2. But we're going to remember that x in this problem is cosine theta. So I want to know where on my circle does cosine equal a negative 1/2. So go look at your circle. And I'm looking for where does cosine equal negative 1/2. Theta is going to equal 2 pi over 3 and 4 pi over 3. And those are my answers. All right, number 19, still a nice and easy one. Change tangent to x plus 1 equals 0. I'm going to subtract 1 from both sides and get tangent theta equals negative 1. So I go to my circle, and I'm looking for where does tangent equal negative 1. It equals negative 1 at 3 pi over 4 and 7 pi over 4. All right, number 20 is going to require that you remember how to factor. So I'm changing all the cosines to x. It's a trinomial, which means it has 3 terms. So I'm going to write 2 parentheses. And what I'm trying to do is I'm trying to figure out what are the first 2 numbers I can multiply together. What times what would give me x squared? X times x. Okay. Then I need to figure out what are the last 2 numbers that I could multiply together that would give me a positive 1. Well, I could put 1 times 1, and I could put negative 1 times negative 1. But I notice that my middle term is a positive 2. So because it's a positive 2, I want the plus 1 plus 1. Now that this is in factored form, I set each factor equal to 0, and I get x equals negative 1. But remember, on this problem, x is cosine, so where on the circle does cosine equal negative 1? Cosine equals negative 1 at pi. And it's the same thing for the second one, so you just need to write it once. All right, 22. On 22, the first thing you need to do is divide by 2. And you get sine 2 theta equals root 3 over 2. All right, well, this is another problem where we're going to go around the circle more than once. I'm going to pull out my scratch paper again. Okay, so I'm going to go draw my circle. That's the first thing I'm going to do. And I'm going to figure out where does y equal root 3 over 2. All right, well, y equals root 3 over 2 at pi over 3 and at 2 pi over 3. So that's my first answer. So I'm going to write down 2 theta equals pi over 3 and 2 pi over 3. And then I have to go add 2 pi to both of these answers. So I'm going to put it over 1. I'm going to multiply top and bottom by 3. I'm going to add the tops. 1 pi plus 6 pi is going to give me 7 pi over 3. I'm going to come and do the same thing down here. I need a denominator of 3. So 2 pi is going to change to 6 pi over 3. I'm going to add the tops. Excuse me. When I add the tops, 2 pi plus 6 pi is 8 pi over 3. Okay, once you get to here, you have to remember to multiply everything by the reciprocal. The reciprocal to 2 is 1/2. So everything's going to get multiplied by 1/2. The tops are going to get multiplied by 1. The bottoms are going to get multiplied by 2. So theta is going to equal pi over 6, 2 pi over 6, 7 pi over 6, and 8 pi over 6. And there's 2 of these that can be reduced, so I have to reduce them. Okay, so my final answer. Pi over 6 is fine the way it is. But 2 pi over 6 can be reduced. I can divide top and bottom by 2 and get pi over 3. 7 pi over 6 cannot be reduced, but 8 pi over 6 can. I can divide top and bottom by 2, and I get 4 pi over 3. So these are the 4 answers that I'm going to go write on my review sheet. Okay, so theta equals pi over 6, pi over 3, 7 pi over 6, and 4 pi over 3. Okay. Number 23 is asking me, when does sine theta equal cosine theta? Well, sine theta just means y, cosine means x, so where on the circle does the y value equal the x value? I'm going to take a peek at my circle. They're not the same right here. They're not the same right here. Oh, they're the same right here at pi over 4. Not the same, not the same, not the same. Close, but that one's a negative, so not the same. Not the same, not the same, not the same. Oh, the same. So far I have 2 answers, pi over 4 and 5 pi over 4. Not the same, not the same, not the same. Close, but that's a negative. So I only have 2 answers, pi over 4 and 5 pi over 4. That's where the y value equals the x value. All right, 24. I'm going to go change the word cosine to x. So we get 2x squared equals 2x. This is a quadratic, so I need to make the right side equal 0. So I'm going to subtract 2x. This is a quadratic binomial, so I'm going to look for a GCF. I have a GCF of 2. So each of these terms is going to get divided by 2x. 2x squared divided by 2x is x. A negative 2x divided by a positive 2x is negative 1. I'm now in factored form, so I make each factor equal 0. I'm going to solve this first one. 0 divided by 2 is 0, and I add 1 to both sides, and I get 1. Remember that we're talking about cosine, So I want to know where does cosine equal 0, and I want to know where does cosine equal 1. Okay, well, cosine equals 0 at pi over 2. So that's one answer. Cosine also equals 0 at 3 pi over 2. That's the second answer. And cosine equals 1 at 0 radians. That's my third answer. I have 3 answers. Number 25, last one. On 25, it wants to know where does y equal the opposite sine x. So where on the circles are the numbers the same, but the signs the opposite? Where on the circle are the numbers the same, the x and the y, but the signs are the opposite? Well, this is a lot like 23. I want to know where they're the same numbers, but opposite signs. So not here, because those are the same signs. Right here, they're the same numbers, but opposite signs, 3 pi over 4. Not here, because they're the same. Oh, right here, they're the same numbers, but opposite signs. So 3 pi over 4 and 7 pi over 4. All right, guys, study hard for your test. Know your unit circle. Know your double angle formula for sine and for cosine. Come in ready to go. Get all your homework and your late work taken care of. See y'all tomorrow. Good luck.